Yes. I think the context document gives us enough of a stable foundation to stop talking abstractly about the project and begin designing the actual training mechanism. It correctly identifies that the census, library debugging workflow, and study binaries exist, while the drill engine, typelab, memory facts, and RustForge are still largely conceptual. And your two clap questions are actually excellent examples of the two different kinds of knowledge your system needs to train. Flags vs commands, rightward arrow API/domain model fluency. What exactly is self here? Rust language slash. Type system understanding those should eventually generate different drills. One clap, flags vs commands. The cleanest mental model is that a command chooses what operation the program is performing, while a flag slash option modifies how that operation is performed. Think of a CLI as roughly program options, command options, arguments. For example, git version, git clone, depth1 HTTPS. Git status short here, clone status are command slash subcommands, whereas version depth1 short are options slash flags. A command usually causes the parser to enter a different branch of the CLI structure. For example, Rust derive clap subcommand enum command copy source string destination string list arg long all bool conceptually my underscore program copy a text b text command my underscore program list all command flag copy means perform the copy operation. All means modify the behavior of the list operation. One terminology detail people often casually call everything beginning with or a flag, but there's a useful distinction. Flag verbose force the option taking a value port 8080 threads for in. Clap both are fundamentally represented using arguments, but the behavior depends heavily on the Rust field type slash configuration. For example, Rust arg short long verbose bool gives you something conceptually like v verbose the presence of the flag produces true. But yours, Rust arg short long fuck underscore u I32 isn't really a boolean flag. It represents a named option whose value must be parsed into an I32 approximately fuck u 123 or f123 then Rust CLI. Fuck underscore u is Rust 123 underscore I32 and because the field is Rust I32 rather than Rust option I32 clap treats a value as required unless other configuration changes the behavior. That relationship itself is worth learning. Rust field shape downward arrow CLI semantics bool downward arrow presence absence flag t downward arrow value expected generally required option t downward arrow optional value vec t downward arrow. Multiple values occurrences depending configuration. This is one of the major recurring patterns you'll encounter in derived heavy Rust libraries. Rust types aren't merely storage. The library interprets the shape of the type as configuration. Serde does the same kind of thing in a different domain. 2. What does self mean? This one is fundamental Rust. Inside a trait, Rust trait something make. Self means the concrete type for which this trait implementation is currently being used. It's a type, not an object or value. Compare lowercase and uppercase. Rust self means the current value. Rust self means the current type. Consider Rust trait create can create. Self struct cat impl create for cat can create. Self cat inside. Rust impl create for cat. The compiler effectively knows. Self cat so Rust can create. Self can be mentally substituted with Rust can create cat in this. Rust cat create returns a Rust cat but self doesn't specifically mean struct. You can have Rust enum animal cat dog impl create for animal. Can create self animal cat now self animal. It can also be something generic. Rust impl t some trait for vec t. Inside that implementation, self vec t so your intuition is that the struct that implemented the trait is basically correct. Generalized to it is whichever concrete type is occupying the implementer position of the trait. 3 now apply this directly to clap you found. Rust pub trait parser from arg matches command factory size parse self. And you're calling Rust letly CLI parse at this particular call site. Self CLI therefore mentally rewrite the method is Rust parse CLI that's why Rust letly CLI parse gives you a Rust CLI the trait uses self because claps authors obviously cannot write Rust parse CLI the trait must work for every parser anyone ever defines. It therefore says Rust parse self meaning parse arguments and construct whatever parser type this method is being called for. For your exact clap function becomes much easier if you substitute CLI take Rust parse self let matches self as command factory command. Get underscore matches letter self is from arg matches from underscore arg underscore matches underscore mut matches map underscore error format underscore error self matches OKSS error e. Exit when called is Rust CLI parse mentally perform a substitution Rust self rightward arrow CLI then it becomes approximately Rust parse CLI let matches command factory command. Get underscore matches letter is from arg matches from underscore arg underscore matches underscore mut matches map underscore error format underscore error CLI matches OKSS error e. Exit. Now the entire thing is much less mysterious. Look particularly at Rust OKSS. What type is S? It's Rust CLI because Rust is from arg matches from underscore arg underscore matches underscore mut is constructing a CLI from the arg matches. The conceptual flow is command line strings command CLI grammar configuration get underscore matches arg matches generic parsed. Representation from arg matches CLI type Rust representation that last transformation is especially important. 5. What is this weird syntax? You also encountered Rust self is command factory command instead of simply Rust self command. This syntax explicitly says call command from the command factory implementation. For self general form Rust type is trait method so Rust self is command factory command means for the current type self look specifically at its command factory. Implementation call command when self CLI Rust is command factory command. This is usually called fully qualified syntax or UFCS style syntax. It becomes useful when several traits slash types may expose methods with the same name and you want to specify exactly which one you're invoking. This is another excellent type lab drill candidate. 6. There's another subtle thing happening with derived parser you wrote. Rust derived parser struct CLI. It may appear conceptually like Rust impl parser for CLI, but claps architecture is more interesting. Notice the trait declaration Rust pub trait parser from arg matches command factory size. That means anything that is a parser must already satisfy from arg matches command factory size. Claps derived machinery generates the machinery needed for your type to participate in that system, and clap can provide the general parser behavior once those lower level capabilities exist. That's why parse itself can be implemented generically. The structure is conceptually derived parser generate knowledge about CLIs. Fields how to construct a command how to construct CLI from arg matches generic parser parse and that explains why parse contains virtually no knowledge of your actual struct. It just coordinates two capabilities Rust command factory and Rust from arg matches. This is a beautiful Rust library pattern worth extracting. 7. This is exactly the kind of thing your fluency lab should exploit. Your debugger study has already surfaced at least 5 separate training targets from this tiny example. CLI parse API knowledge remember Rust CLI parse trait knowledge understand Rust trait parser from arg matches command factory size self predict that Rust self CLI fully qualified trait calls read Rust self is command factory command without cognitive friction. Transformation pipeline understand ARGV rightward arrow command rightward arrow arg matches rightward arrow from arg matches rightward arrow CLI. A normal flashcard tends to collapse all of those into something like Q. How do you parse arguments with clap? A. CLI parse that's useful, but it captures maybe 10% of what you've just learned. 8. I think the central fluency lab primitive should be a micro workflow, not a question after seeing the actual repository state. I would make this the first major design decision. The atomic object should not be question rightward arrow answer. It should be initial state downward arrow objective downward arrow actions performed by you downward arrow real compiler runtime feedback downward arrow. Success condition something like trill clap basic underscore option start partially implemented CLI goal support app port 8080 constraints port must become U16 long and short forms no documentation compile and run it success cargo run port 8080 prints 8080 you type maybe 3 to 6 meaningful tokens slash lines. The exercise takes perhaps a minute, but you're actually programming. That is very different from answering, which attribute creates a long argument. 9. Then mutate the same micro workflow. The single biggest way I would increase learning density is not creating completely unrelated exercises every time. Take one working artifact and repeatedly mutate the requirement. For example, rep 1 make port accept a U16. You produce Rust arg short long port U16 rep 2 now make port optional. You need to independently realize Rust port option U16 rep 3 now replace it with a boolean verbose switch. You need Rust verbose bool rep 4 now add a copy operation app copy source test you've crossed from arguments into Rust subcommand rep 5 now add force only to copy. You've learned nesting. Rep 6 give intentionally broken code Rust enum commands. But forget some derived slash annotation and require you to diagnose Rust. Rep 7 no coding before running it. Predict the type returned by CLI parse. Rep 8 source trace step into parse. At self is from arg matches from underscore arg underscore matches underscore mut. Predict what type OK underscore contains before stepping. Now one clap pattern has received repetitions through recall construction mutation debugging prediction source reading. That's far more powerful than 8 independent trivia questions. 10. I would therefore model mastery as a matrix instead of saying I know clap parser. Track recall build modify debug explain transfer parser. Parse subcommand value enum command factory from arg matches self. UFCS? This gets you closer to what mastery actually means. A pattern isn't mastered because you got a flashcard right. It's mastered when you can recognize it, recall it, construct it, alter it, debug it, explain it, use it somewhere else. 11. Your close website then has a very clear role. I wouldn't abandon the close idea at all. I would just constrain what it's responsible for. Close is excellent for making expensive retrieval cheap. For example, Rust derive underscore 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 struct CLI arg underscore 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 port U16 or Rust let CLI underscore 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 underscore. These make parser short long parse from arg matches command factory come out of your fingers automatically. That's valuable. But the Fluency Lab verifies that those tokens are connected to an actual behavioral model. So I'd make the relationship source study debugger discover pattern pattern model contextual drills memory extraction close repetitions transfer tests that seems much closer to the actual architecture you are trying to discover. 12 PowerShell / bash should probably be trained inside the ritual. I think your earlier shell experience reveals something important. Don't make PowerShell commands primarily another subject to memorize. Make PowerShell / bash the control surface through which you perform Rust drills. For example, a drill deliberately requires find the relevant file, rightward arrow rg command factory, rightward arrow open it, rightward arrow cargo test, rightward arrow run one binary, rightward arrow inspect git diff, rightward arrow locate symbol. Then you are getting shell repetitions as a side effect of accomplishing something you actually care about. If you need RG 20 times per week because your Rust gym requires it, you are far more likely to spontaneously use RG in real projects. That's exactly what was missing from the Anki approach. The distinction is memorize what command searches recursively versus habit. I need to locate this implementation. Downward arrow your hand automatically types RG command factory. That's the level you are targeting. 13 a first version of the daily 1 hour ritual. I wouldn't build much software around this yet. We should first manually test the ritual and discover what works. I'd experiment with approximately 10 minutes fast retrieval close tiny reconstruction API syntax common trait shapes shell operations 20 minutes micro workflows 3 to 6 tiny actual coding tasks compile run each node docs during attempt 10 minutes mutation debugging modify something already working or repair intentionally broken code 10 minutes type lab predict types ownership trait resolution compile to falsify prediction 10 minutes real source clap rayon et cetera debug 1 narrow path extract 1 to 3 things you didn't understand critically. The last part generates tomorrow's material. So you get a closed loop. Real library downward arrow discover friction downward arrow micro drill downward arrow repeat downward arrow close exact syntax when useful downward arrow mutation debugging downward arrow transfer downward arrow real library again. Now your census has a purpose. 2. It tells you which patterns are worth entering this loop first. 14 I would not build Rust forge yet your context document correctly leaves its meaning unresolved. I think we need empirical information before defining it. First manually create perhaps 20 to 30 clap drills. During that process we'll discover what information every drill actually needs, whether drills need starter code, whether mutations can be automatically generated, how solutions should be hidden, how tests should determine success, how hints work, what should become closed material, what metrics are actually useful. Then the shape of RustForge will probably become obvious. Otherwise there's a risk of designing a very elegant drill platform before knowing what a good drill is. One small concept I'd like you to keep while continuing through clap whenever you encounter code like Rust parse self. Try this mental operation immediately. What is self here? Then substitute it mechanically. For your current trace, CLI parse self is command factory is command factory self is from arg matches CLI is from arg matches result self underscore result CLI underscore OKSSS. CLI parse self parse CLI. If that substitution becomes automatic, a surprising amount of generic Rust code suddenly becomes much easier to read. And that itself is exactly the sort of tiny, high-frequency cognitive operation the Fluency Lab should turn into a ritual.
So I don't think that GPT gave a good system there. Sure. I still don't know. I have no idea what I'm gonna do to train. Best way is to build things, but then it's too slow. I'm not really sure what I can do. The close cards is a good idea for memorizing stuff, but then I'm concerned I'm gonna get into the same situation as the Anki stuff, where I try to memorize a bunch of PowerShell commands, and then I never use them because they are not parts of a workflow. But since I don't know the context, there's never the muscle memory to just go, like for example, instead of looking at files on the IDE, to use PowerShell to read the content or stuff like this. I don't want to get into the same problem here. Then if I redo this each time, I think that's too slow. And also, it's very hard to remember everything. Maybe it's SD path buff, I think. Maybe it's like this. Path buff. Flap. I really forgot here. And maybe it was like this. And sub commands. Maybe I do remember some parts. So here there was another macro, shorts, long. Well, then for the subcommands, I don't remember really well. Maybe just subcommands and then yeah, there was an enum. Not sure. This is another question: is whether or not I need to define this enum for the subcommands. Yeah, I don't remember. This command, subcommand. Also, I have to use on the enum. Right, subcommand. Maybe here is just arc. I was saying commands there, but sure what, where does it come from? If I do here, like I don't understand why. Because from last time that I remember that I was stepping over or stepping into, the name was something to do with the parser itself or the file. I don't think that's this macro is, maybe it is because there isn't anything related to this command here. Unless it's indirectly getting from these domains here, these keywords. I don't understand where this comes from, so I'm just gonna ask GPT. Because I think here it doesn't make sense to be related. I think this is more configuration stuff. Just copy, let's see. Something else. So I think that's maybe it has to be the same name. Like here, just convert. Yeah.
times. Compile time your struct downward arrow derived parser downward arrow generated clap configuration generated. Extraction code runtime ARGV. OS string downward arrow clap parser downward arrow type values stored in argmatches downward arrow generated from argmatches code downward arrow CLI fuck underscore u 123 underscore I32 for your exact example. Rust use clap. Parser derive. Parser struct CLI arg short long fuck underscore u I32. The fact that the field is in I32 is visible to the derived procedural macro at compile time. Claps derive API uses that type information to configure an appropriate value parser for the generated argument. Current clap documents this as an implicitly selected arg value underscore parser. Ordinary parsable Rust types. Can use from str, while clap also has specialized type parsers for things like integers and enums. Docs.ars plus 11. First, the executable receives OS strings suppose you run my underscore program fuck you 123 at the beginning. Rust does not have this. Rust 123 underscore I32 it effectively has command line tokens more like OS string my underscore program OS string dash fuck you OS string 123. Parser parse uses std env args underscore OS, specifically so clap starts. With OS native strings rather than assuming everything is valid UTF-8. Docs.ars so at this point, 123 is absolutely not an I32 yet. To the derive macro already generated a description of your CLI at compile time. Derive parser inspects. Rust fuck underscore UI32 end. Rust arg short. Long it generates machinery that lets clap construct a command. Command factory exists specifically to create the command corresponding to your user-defined parser type. Docs.ars conceptually not literal macro output imagine it generating something roughly like Rust. Impl command factory for CLI from command. Clap. Command clap command. New. Arg clap arg. New fuck underscore u. Short f long fuck u value underscore parser capable of producing I32. The important part is this. Rust. Value underscore parser I32 parser so before your program even runs. Clap already knows. Argument fuck underscore u CLI spelling. Fuck you f expected Rust value type. I32 that's the bridge between your structs Rust type and runtime command line parsing. 3 CLI parse builds that command you already found this code. Rust parse. Self let matches self is command factory. Command.get underscore matches. For your program, self CLI so mentally substitute. Rust let matches is command factory. Command. Get underscore matches the first operation. Rust is command factory. Command constructs the parsing grammar derived from your struct. Conceptually, CLI command factory command arg fuck underscore u short f long fuck u required. Value underscore parser I32 parser help version etc a clap command. Contains the arguments, subcommands, parser behavior, and other information necessary to parse a CLI. Calling its get underscore matches family begins runtime parsing. Docs.ars plus 14. Clap recognizes the argument before worrying about I32 now it sees. Fuck you 123 the parser machinery essentially asks, what is dash fuck you? Looks it up. Command arg id fuck underscore u then it knows that this argument consumes a value. So, fuck you 123 raw argument value gets associated with that arg. Still no struct has been constructed. 5 now the value parser converts. 123. This is the crucial piece. Each value taking arg can have a Rust value parser clap describes value parser specifically as the mechanism that converts raw argument values into validated type values. Docs.ars the lower level abstraction is Rust type value parser whose parsing operation conceptually has the form Rust OS string OSSTR downward arrow result T clap error. The current API's type value parser parses an OS string into its associated value type. Docs.ars for your field. Rust fuck underscore UI32 that T is effectively Rust I32 so the conversion is conceptually OSSTR 123. Parser selected for I32 123 parse 123 underscore I32 for normal Rust types. Clap can infer parsers based on the type. Its derived examples explicitly show fields like usize and IP address being parsed implicitly via from str. Docs.ars so at some layer this ultimately corresponds to the same fundamental Rust concept as Rust 123 parse I32 which is syntax sugar around the types from str implementation. Conceptually, Rust I32 is std str from underscore str 123 returns Rust OK 123 underscore I32 or Rust air parse inter. 6 This explains that range I64 value parser you saw in the debugger your existing clap trace specifically recorded going through the value parser machinery and arranged integer parser during numeric conversion. That's because clap can use specialized type parsers for numeric types rather than having every integer behave as a completely generic box from str parser. Current clap exposes parsers including range I64 value parser and range U64 value parser. Docs.ars so you might see something internally resembling raw OSSTR downward arrow range I64 value parser I32 downward arrow numeric conversion downward arrow. Range type validation downward arrow I32 rather than literally stepping into Rust str parse I32 immediately. But conceptually the job is still turn this command line token into a valid value of the Rust type declared by the field. 7 Here's the subtle part. Arg matches already contains the I32. This is where I would change the mental model from our previous discussion. You might imagine ARGV downward arrow arg matches containing strings downward arrow from arg matches parses strings into CLI but that isn't quite right. The better model is ARGV downward arrow value parser downward arrow type values downward arrow arg matches downward arrow from arg matches downward arrow CLI for example. Clap's own builder documentation shows parsing dashboard 3001 and then retrieving Rust lit port U16M. Get underscore 1 port dot unwrap so the arg matches already hold something retrievable specifically as a U16, not merely 3001 waiting to be parsed later. Docs.ars conceptually your matches contain arg matches fuck underscore u type value 123 underscore I32 internally the container has to erase slash conceal the concrete types because one arg matches can hold heterogeneous things. Name, string port, U16 verbose, bool threads, usize mode, some enum path buff but those values have already been produced as their proper Rust types. 8 Then from arg matches constructs your struct. Now we reach the second generated piece of code. Claps from arg matches trait exists specifically to convert Rust arg matches into Rust self and it is derived as part of parser. Docs.ars the macro effectively generates code conceptually similar to Rust impl from arg matches for CLI from underscore arg underscore matches underscore mud matches mud arg matches result self clap error OK CLI. Fuck underscore u extract type I32 from matches think approximately Rust CLI fuck underscore u matches. Remove underscore 1 I32 fuck underscore u dot unwrap. Again, that's illustrative rather than guaranteed byte for byte macro expansion. The important thing is not 123 downward arrow from arg matches downward arrow I32 but 123 downward arrow value parser I32 downward arrow 123 underscore I32 downward arrow stored in arg matches downward arrow from arg matches extracts I32 downward arrow CLI fuck underscore u 123 clap zone from arg matches documentation. Illustrates exactly this role. Values are retrieved from arg matches using typed accessors such as get underscore 1 string while flags use operations such as get underscore flag. Docs.ars 9. Put your entire function together you found Rust parse self let matches self is command factory command. Get underscore matches letter self is from arg matches from underscore arg underscore matches underscore mud matches map underscore error format underscore error self matches OK ss error e exit 4 Rust CLI parse expand the meaning self is command factory command becomes build command generated from CLI's definition then get underscore matches does ARGV program dash fuck you 123 recognize argument find its value parser parse 123 underscore I32 arg matches then CLI is from arg matches from underscore arg underscore matches underscore mud does arg matches extract fuck underscore u is I32 CLI fuck underscore u 123 and finally Rust OK ss where Rust CLI so Rust likely CLI parse ends with CLI fuck underscore u 123 underscore I32 10. This is a really nice example of compile time metadata driving runtime behavior. The full architecture is source code derived parser struct CLI arg short long fuck underscore u I32 procedural macro compile time generated behavior command factory for CLI argument identity fuck you requires a value parser for I32 from arg matches for CLI extract I32 and put it into CLI runtime std env args underscore os app dash fuck you 123 command parser and this distinction is worth bringing into your Rust mental model. The procedural macro does not parse your command line. It writes Rust code slash configuration at compile time that tells the normal clap runtime parser how your command line should be parsed later. That's why you can meaningfully step into the derived macro while debugging the executable. The derived macro already ran while compiling. At runtime you are stepping through the code and structures it caused to exist. Plus claps ordinary parser machinery. Docs. Rs plus 1 This exact example is also an excellent fluency lab pattern because it connects DROC macros right arrow generated trait and please right arrow trait based construction right arrow type directed parsing right arrow type erasure right arrow type extraction in one. Relatively small execution path.
sure if I understand this here. sure what's going on with ChatGPT now. It's very slow. What I don't understand is saying it's part of the parser macro. But then I don't understand how it doesn't work when I was doing that. It doesn't make any sense. Maybe it was a typo or a different type I was using there. Because ChatGPT is using a smaller case for the S. The other thing I really don't like is that according to ChatGPT, it generates the code that is gonna parse the there's gonna translate the arguments, the flags into their types using the macro. But at compile time, it generates the code that is gonna parse on runtime. And then this makes it difficult to figure out what exactly it's doing. Because I still don't understand there. Like I roughly understand that it's gonna take that string you pass to the executable and it's gonna create that OS string. But then how does it take from the OS string to the actual type that you have on the struct? It's still unclear to me exactly how that works. According to ChatGPT, it's gonna use an algorithm that is built in Rust that from that string type, from the OS string type, it calls the parse algorithm or something like that. And that translates into the specific type. That is kind of it's very confusing. Maybe it's this thing that converts. Not sure though. Another thing I wanted to ask is I wanted to see actually. I do that. I'm just gonna delete everything. I think it's because of the I was doing like this, yeah. So it was a lower case there, but I don't understand like where does it. But yeah, I guess that's the thing is like the reason why it's hard to figure out is because it's gonna come from the compiler. So the macro creates the code at compile time, and then you have to guess like what happens. That's why it's confusing. I actually really don't like this, to be honest. It feels really fucking dumb. Because then unless you created the API yourself, there's no way to know. Unless you do that annoying thing that ChatGPT is recommending, just in cargo expand or something like that, to generate the code for you. But maybe like that's it. There can't be any other way because otherwise it would be pointless to use the macro, probably. But maybe not. Because the macro still has code on most cases. So I think that is just something weird that on this case, for whatever reason, it doesn't have the definition there. Maybe it's just like because of this type of macro that might be different than other types that I've seen. Because I know there's two main types, I think, but I don't remember the difference between them that much. This is I think it's procedural macro, and the other one static or something like that. So maybe because it's a procedural macro, it doesn't have the definition. Or maybe I can go here and see. I think that this is just like a generic thing. Maybe here. Obviously, what annoys me about this is that I have to. There is no easy way to know. I want to know like what are the possible things that I can do here, because this specific thing is not coming from anywhere. So because yeah, I don't understand like where does it come from, and I assume obviously it's gonna be based on like whatever is happening under the hood on the compile timers at some point. But then there's no way to know. So like you kind of just have to guess, or you have to read the documentation first, or spend a bunch of time reading. Oh, there's here commands arg here. Yeah. This kind of sucks, to be honest. And this is a common problem, I think, everywhere. Like the reason why it's so hard to make good things is because like everyone is working at a higher level of abstraction, and then underneath this there's a bunch of black boxes, and it's because of these types of things. So you rely on everyone else's assumption, so it makes it impossible to build like something to simplify things because everything accumulates over time. Like if you're gonna build something on Rust, then you create more black boxes on top of that. It just keeps accumulating. It's very frustrating. And obviously most people don't care about, so they just use, but then like you create this double-edged sword, and I think like society as a whole is like that nowadays. Where like everything is extremely complex and nobody understands the whole thing. So it becomes very fragile because then like at some point it's gonna become so complex that nobody's gonna know. And Ted Kaczynski talks about this, or talked about this, that everything's gonna become so complex that people are gonna become slaves of things that they don't understand. There's an experiment as well, psychological experiment about this, where they put a group of monkeys on a cage, and then they put a banana, and then every time that one monkey went to grab the banana, they uh, hit him with water, and then through generations, the monkeys didn't grab the banana, and they didn't know why. And that's pretty much what's gonna happen here, I think. Hey, what's up? Yeah, no. And maybe I should go over the other libraries. Like, there's there's another problem. There's like a lot of libraries that I have to study, and I don't want to spend too much time on this one. And I need to have the agent do this other ones as well. Because I currently only have 5. So I need to see on the reports the other ones, have the agent create the configuration for all of them, and create this like main file as the entry point. So I should probably go over with the debugger superficially over a lot of them, and then just mentally try to get on my subconscious mind the fundamental patterns across them, and then think about the exercise. Because right now I'm thinking on how can I transform, like how can I create an exercise based on this? And the first thing that came to my mind is obvious. The first thing is just create another file and try to reconstruct everything from scratch without looking at the original one. But that I think is kind of too slow. Then the other thing would be to create like a very small program, and then maybe this program is done in such a way that I can, each time that I look at it, I can change something about it to train. But that feels kind of annoying as well, because then you have to think about like what program you're gonna build, and then it's just more things to think about. I don't think that's very good. I'm not sure what is the best way to see the actual implementation when I have the trait. Also don't because if I press F12 it comes here, then if I search like here it takes too much time. It's very annoying. And maybe I'll do like I'll do several examples, like create a program that receives a count. Can I do that? Would be interesting. One thing that I'm thinking about is whether or not I can do several different structs and then just use the parser, then call the function here. I think that I need to think about like one program that that is interesting to do and that is subdivides into several different other programs. And then think about how to do like a progressive thing where I can have like receive a count flag or a name flag uh, and print it maybe. Yeah, this is the thing. Like, if I'm gonna if I'm gonna think about a program, is the problem is that like anything interesting is gonna combine several different libraries. That kind of defeats the purpose. And I think that creating small things is too slow, probably. For retention is obviously better to create a project, like for understanding, and then for remembering the API, the exact API is better to create like a simple memorization thing. Not very hard to think about like what should I do in the middle. Maybe maybe what I should do is just spend time studying, like going over the debugger and then writing down these questions on a main file that I have like all the questions for all the libraries about Rust, the fundamentals of Rust. Then I think about a project that I can do after going over all the libraries that combines them. And then on top of that, like a project that combines them and is related to building or to improving the learning system as well. I'm gonna stop streaming now, and I think that's what I'm gonna do next time. I'm just gonna go over. I need to go over several different libraries, I think, first, and then capture patterns because I can't think. Yeah, it's very hard to think about something that combines both the understanding you gain from building a project and the memorization from something like simple that's just a repetition. And it feels kind of pointless to just like keep reconstructing this. Not really sure. Maybe that would help. If every time I just come on this file and then I try to rewrite the main, maybe that's good. But it feels kind of. The thing that annoys me as well is like it's very hard to understand like how does it work because of these types of things here. So I'm thinking that this is probably what I should focus on first. Is like write down these questions about these things that are hard to understand, about the macros and stuff, and then spend time studying those things. Going back to reading the book and maybe like explore somehow the source code or talk to GPT to try to like build a plan to clarify these things. And as my understanding of each of these patterns increases, it becomes easier to study the libraries as well. Then I come back and think about specific exercises. Maybe that's the best way. Because I can't think about anything good right now that I could do that would like help. But I think spending too much time on a single library is probably a trap as well. Because then like there's diminishing returns for the amount of things I can understand. I think that the highest return is to try to clarify the fundamental questions. Like how does this work, for example? How does the parser work here? And I think yeah, that's probably the best thing to do. So go over, use agents to finish the setup for more libraries, and then just go over each one very fast. Then try to write down the superficial things that are like points to clarify. Then after that, I think about an exercise. I think probably there isn't like a way. The most interesting thing to do is probably a project that helps me build a learning system or that I can implement on the website. Like I build a project that helps build the learning. That's probably the best thing to do. It's like a meta thing. And that involves multiple different libraries. That's probably what I should do. So I'm gonna stop here. Probably next time I'm just gonna go over the next one, which is Rail. And follow the plan that I just said. So see you then.